versus sodium borohydride. We know these two are very good reducing agents. They play very important role in reduction of organic compounds. So first let us see which is stronger reducing agent. No doubt when it comes to power, lithium aluminium hydride is stronger reducing agent than sodium borohydride. What may be the reason for this? Generally, we have never asked about reasons for stronger reducing behavior between these two. But when we talk about reason, we know in lithium aluminum hydride, LiAlH4 minus is there, which is hydride ion donor, and BH4 minus. So aluminium hydrogen bond is like this, boron hydrogen bond is like this. It means it is clear that Al and hydrogen bond is longer, this is shorter. Although in both the species aluminium and boron are sp3 hydridized, both are sp3 hydridized, but what I am talking, so this one is longer than this, because the reason, you see, aluminium and hydrogen, you see, aluminium and hydrogen, one s orbital is there, aluminium hybrid orbital is like this, okay. This is not the actual shape of hybrid orbital, but I am taking like this. This is boron and hydrogen. Overlapping takes place like this. Overlapping takes place like this. This is of hydrogen, this is of aluminium. Boron hydrogen. Bond is shorter, bond is longer. Bond is longer. What the reason for this? We know this one is sp3 but third orbit. This one is sp3 but second orbit. 2 sp3. Boron belongs to second period. So second period means s orbital and p orbitals of second period participate in hybridization, and s orbitals and p orbitals of third orbit participate in hybridization. Obviously these hybrid orbitals are more diffused than this. So that's why aluminium hydrogen bond is longer than BH bond. So this bond is longer means weaker, it can donate hydride ions easily. So this is actually the reason behind stronger reducing power of lithium aluminium hydride. So now let us see the mechanism of this reaction. Actually both lithium aluminum hydride and sodium borohydride are hydride ion donors. So when we talk about the mechanism like this, I have taken a carbonyl compound like this. It is a planar molecule. Okay, planar molecule means I have taken like this. Front side, okay, this bond is present. Back side, this bond is present. Otherwise, you can also take like this. Back side, this bond you take, and front side, solid line, that is wedge line, wedge and dash. Okay, overall it is planar. When we take sodium borohydride along with ethanol, it gives this particular product. Okay, make it sure that this hydrogen comes from, okay, this hydrogen comes from alcohol and this hydrogen comes from our reducing agent. What is the mechanism of this reaction, sir? You see, this carbonyl group is there, and BH4 minus means I am writing BH3H, and this one donates lone pair, that is in the form of hydride ion. It attacks this and bond shifting takes place. Now sp2 carbon becomes sp3 carbon. Okay, so this C and H bond is obtained from the reducing agent, that is sodium borohydride. The mechanism is same for lithium aluminum hydride as well. And from this ethanol, that is solvent, we know, from the solvent it takes up H plus ion and we will get this particular final product. The mechanism is so first we came to know that which is stronger reducing agent. In the next step we have seen the mechanism. This mechanism goes through hydride ion transfer from reducing agent to the substrate. And now you see, so actually sodium borohydride is given in NCERT textbook also, solvent is not mentioned. You can take sodium borohydride along with any solvent like ethanol, water, like that. But when it comes to lithium aluminum hydride, we cannot take like this. I mean, we don't need to take, that will be given in the question. But actually, from NCERT textbook and other reference books also, we can understand that when we are given lithium aluminum hydride, we are also given water in the second step. What does it mean? Actually, lithium aluminum hydride is very highly reactive. It reacts explosively with solvents like water, ethanol, etc. So that's why lithium aluminum hydride is taken with any inert solvent like THF, tetrahydrofuran, or any anhydrous ether, like that. So first this reaction takes place, and after completion of reaction with lithium aluminum hydride, next we add water. So this is the meaning of 1 and 2. So overall the product will be same. Product will be same. Okay. This one we got from the solvent. Okay. This one, and this one CH bond is obtained from lithium aluminum hydride, because for competitive examination, in place of water you may be given D2, in place of LiAlH4 you may be given LiAlD4, okay, NaBH4 or ETOD, like that. So properly you have to write the product. Now we came to know that lithium aluminum hydride is stronger reducing agent. It reduces almost all functional groups, as in chlorides, esters, amides, okay, but products are different that you study at relevant places from NCERT. But altogether, lithium aluminum hydride reduces almost all the functional groups, okay, except alkenes and alkynes. So what is the reason behind that one, sir? What is the reason behind this? Actually, from lithium aluminum hydride, the reactive species is hydride ion. Okay, some functional groups like this one, carbonyl group, it is a polar. What? It is a polar multiple bond. But these are non-polar multiple bonds. Charge separation is there. Hydride ion, okay, can attack this carbon. This is electrophilic carbon. But here no charge separation, nothing. And moreover, we know above and below these molecules, I mean alkenes and alkynes, pi electron cloud is present. Suppose this is alkene molecule. Above and below pi electron cloud is present, that is actually pi bond. So pi electron cloud is negatively charged. Hydride comes along with negative charge, that is electron rich. So repulsions take place. So because of these repulsions, lithium aluminum hydride cannot reduce multiple bonds, that too non-polar multiple bonds. It can reduce polar multiple bonds, no problem. But sodium borohydride is highly selective, because of its weak reducing nature, it reduces some particular functional groups only, that is aldehyde to primary alcohol, ketones, okay, R prime, I am writing like this, ketones, acid chloride, like this, okay, and imines. Only these functional groups can be reduced by sodium borohydride, but these two are very famous, given in NCERT and for competitive also. So these are frequently used substrates for sodium borohydride. It cannot reduce multiple bonds, just like lithium aluminum hydride, because it is also hydride ion donor. So just like LiAlH4, it cannot reduce non-polar multiple bonds. Okay, so this is the chief difference between lithium aluminum hydride and sodium borohydride.